Physicists describe it as the most dangerous substance in the whole universe. A particle so unstable that the instant it collides with ordinary matter, both vanish in a flash of pure energy. It sounds like something that should be hidden away in secret laboratories, sealed behind heavy doors, and guarded. Yet the reality is much stranger. Antimatter isn't hidden away, it's here. In hospitals. And every single day, doctors create it and use it on us. Imagine looking into a mirror, and instead of seeing just your reflection, you see your opposite. Same weight, same shape, but reversed. That's what antimatter is. It's the twin of matter. Instead of an electron with negative charge, we have its twin, a positron. The same weight, but a positive charge instead. I still remember visiting CERN in Geneva a year ago. I was touring the main facilities, including Antimatter lab. The interns there explained it really well. I could finally get a good grasp of what antimatter actually is. But once with the answers, I was left with more questions. How did we discover antimatter in the first place? And why are we so sure that the universe created antimatter and matter in equal amounts after the Big Bang? And if this stuff vanishes the instant it meets ordinary matter, why would scientists at CERN try to recreate it? And why would doctors try to inject it into their patients? Well, the answers begin not in a lab, but on paper. 1928. Physicist Paul Dirac tried to merge Einstein's relativity with quantum mechanics. His math produced a strange second solution, a particle identical to the electron, but opposite in charge. At first that might look like an error, but in math, an extra solution often means something real. It's like x to the power of 2 equals 4. Both -2 and +2 are solutions. So Dirac's extra answer hinted at a new particle. And only 4 years later, it was actually seen. In 1932, Carl Anderson was studying cosmic rays using a cloud chamber, a box filled with vapor, where invisible particles carve visible streaks, like the contrails behind airplanes. He placed this box in a magnetic field. This field acted like a secret code. Heavy particles like protons, they bend only slightly, while light ones like electrons, they curve sharply. Also, the direction of the curve reveals the particle's charge. One day, Anderson observed a trail that bended just as tightly as an electron, but instead of bending left, it bent right. It was too light to be a proton, yet wrong charge to be an electron. This was clearly no math mistake. This was Dirac's mirror twin caught on camera. This was the first antimatter particle ever seen, the positron. Here is a great cosmos paradox. Physics tells us that matter and energy are both different sides of the same coin. When antimatter and matter collide, they both vanish into pure energy. But the reverse is also true. With enough energy, particles can be created, always in pairs. One antimatter and one matter. Just like shoes in a box, they always come with the left and with the right. So the Big Bang should have created both in equal amounts. And if that were true, they'd have annihilated, leaving behind nothing but light. No stars, no galaxies, no people. Yet here we are. Somehow matter gained the tiniest edge. For every billion of pairs that destroy themselves, one particle of matter survived. And that became everything: the universe, the planets, us. So in a strange twist of tale, the most dangerous substance in the universe is also one of the most delicate tools used in medicine. Beautiful. When a patient lies in a PET scanner, they carry an invisible cargo of antimatter, positrons, which are the anti-electrons that are drifting throughout their blood. And each of them survives less than a blink of an eye before colliding with an electron and vanishing into a flash of energy and releasing 2 faint rays of light. The scanner collects those flashes, billions of them, and assembles it into a living map of the body. Not just shapes, but the chemistry of it. Where sugars are burned, where cells divide too fast, where diseases hide. So yes, injecting antimatter into human beings definitely sounds frightening. But here's the truth, those doses are unimaginably small. A few billionths of a gram, gone within minutes. Before the patient even leaves the hospital, every positron has been long vanished. So the radiation is no more dangerous than a long airplane flight. The PET scans are safe, with the benefit of detecting cancer, measuring the heart, and mapping the brain. So every time someone asks, why do scientists waste so much time studying things so far away from real life? Remember this. Antimatter. Predicted on paper. Observed in cosmic rays. Studied in accelerators. And today, a cornerstone of modern medicine. What once seemed like useless knowledge became a technology that saves lives every day. And that's only one story.